learn the Docker. We have almost 15 to 20 hours of content. You can just say master Docker, skill up with Stan. I have sent the playlist this morning. You have it in Tamil as well as in English. Okay, you have a series of videos around Dockers, how to install, how to create containers, and so on. So you can just open this and then you can learn one by one. It is very small videos. You just have to spend maybe 2 to 3 hours in order to learn this. Yeah, so you can just go and do that. So you and I have given 25 differences for your virtualization and containerization. Okay, so yeah, I'll just give you some briefing before we get into Azure Container Instance in that case. Okay, so Docker. Okay, so earlier, again, going back to the previous virtualization era, at that time, developers will be creating application, software application. The entire software application will be bundled into one single package, and then we will run it as a in a VM. We will run it in a VM. That's what we used to do. But now there is a very large competition. So teams have to work quickly and then provide updates or releases very quickly. So app releases has to be very quick. So if you are not doing that, what will happen? So the business will is very competitive now. It's very agile nowadays, and whoever is giving the features and functionalities quickly, they will take up the market. So to attract the market, to attract the business, to attract the business end users to stay quick in the latest features and functionalities, the software development team has to create a lot of different packages into a small bundle. And this requirement to provide updates and releases very quickly, things have changed. The developers have started working on a daily basis. They have to provide regular updates. So if you know about agile framework or the Scrum framework, what they generally do is they have a Scrum call on a daily basis, and then they will have to update what has been changed, where are we with the updates, and we have a regular daily meeting instead of having a weekly meeting for having new updates to a software application. Nowadays we have daily meetings, and the developers have to provide the updates on a regular basis on what has been changed on that particular module, what is the new feature that we are bringing in. This has also significantly reduced the time that we need to make changes, and the downtime is reduced. The management cost of the containers has also reduced. So now instead of having one single application, every single process or service is now packaged separately as a microservice, and it can run independently as a container. Okay, so earlier we used to run the application in a VM. Now we are running it as a container. Okay, as a virtual machine, and now we are running it as a container. So instead of wasting a lot of time in OS management, physical server management, now the business is only focused on developing new functionalities, features for your application. So you need more developers in the current modern world instead of system administrators and so on. See, that's the reason there is a lot of demand for DevOps and developers in the modern era. So earlier, like 15, 20 years back, we need a lot of equal number of system admins, the virtualization platform, and developers. So here we used to have a more number of system admins were needed because we need to manage the physical data center, physical Physical data center, we need to manage the physical infra, the hardware, servers, switches, and so on. And we need to manage the operating system. Here, we just need to manage the virtual infra and the operating system. Here, we are just managing only the containers. There is no, I mean, there is very limited physical infra. There is very minimal. There is very minimal physical infra, OS, and data center size. Okay, it is pretty much easy. So here we need more developers and DevOps engineers, or I would say reliability engineers. Okay, so currently that is what is the situation. We don't need a lot of system administrators because we don't have that many number of hardware to manage or operating systems manage. And also this has parallelly evolved. So earlier, when we need hundreds of physical server, we used to have our own data center to run the servers, physical servers, and all those things in our on-premises. And during virtualization, we happen to move towards VPC or managed private cloud or hosted private cloud. So we used to move towards the co-location, or we went to a large company data center facility, right? So we started moving our resources to a co-location facility where companies like IBM or HP or big companies, they started providing virtual private cloud or hosted private cloud using that virtualization technology, and they started reducing the data center size. Even same like our own hard data center, VMware, no, not I mean IBM, HP, they had very huge data centers, and in order to run 100 virtual machine, we need very less number of physical servers, right? So their data center size also shrunk a lot, and they had a lot of capacity where they can accommodate different customers. So IBM, HP, companies like this, they had a very good processes of managing data center. They were IT companies, and they were having a lot of options to replace the hardware. They were able to efficiently manage the failures, and because they had the technology with them at the hardware infrastructure level, so most of the companies started co-locating their applications or servers in a kind of shared infrastructure in a provider location. So they moved towards shared infrastructure at the data center level. Here we had dedicated infrastructure for our customers, and that moved towards your shared infrastructure concept in a virtual private cloud or a hosted private cloud. We started running our application servers on a third party company, so they will provide you the number of racks and the power, cooling, the maintenance, and all those things will be given as a service for you. So that was the transition that we had earlier. But now what we have is everything is on public cloud these days. So we are running on completely on third party data center. So most of our workloads have migrated towards public cloud. So where we don't have to really spend time on managing the physical infrastructure, even there is no operating system to manage. And that's the reason the number of data center management team is mostly shifted towards Amazon or Google or Microsoft. Nowadays the data center administrators are can be seen only in big companies like them, IBM or HP. Rest of the companies, they have already almost decommissioned their own data center. They have very small footprint in their own data center. Maybe they will have only 5-10 servers, which is having some hardware dependency, or they need to be connected to the manufacturing unit or whatever. So only very few servers that cannot be virtualized is still in the data center. Whichever can be virtualized, it's already migrated towards cloud, and whichever can be containerized, all those things can be has been migrated towards your public cloud. So here migration from physical to virtual was happening. Here migration, or I would say modernization or containerization, is what is happening nowadays. Okay, so the developers are containerizing the application that we need, that we are using, and we are moving it to containerized platform or PaaS offering in Azure or AWS or whatever stuff is what is happening currently. So earlier we used to do migration. Now we are doing a modernization or containerization. The software developers are packaging their business requirement into a software package, and they are running it on a containerized workload. So here with Docker, so we have the development team who creates the software package, and they create the containerized image, and that image will be, if the image is running, so running image is called containers. When it is running state, they are called as containers. Okay, and here also we have the operations team. Okay, so we have the ops team who actually does the deployment of the packages or managing the host infra, OS, the patching, packaging, and all those things will be done by these two teams. So this model was very eminent or very useful in the physical infrastructure or in virtualization era. This model was okay. Having a separate development team, operations team was okay. But then when the development team started complaining, so I have provided the software package to operations team 1 week back, but still they are deploying it and testing it, and we don't have clarity on what is the status. And we used to have a separate segregation or split between the development and operations team. So the development team will have developers, and then they will have team lead, and then they will have their own managers whom they will be reporting in the hierarchy. Similarly, here the operations team will have operations engineers, system administrators will be reporting to the ops lead or the ops team lead, and then they will be reporting to a separate ops manager, operations manager. So this kind of had a very big wall in between. So we had a separate development manager, development team lead, and when this particular development team want to send something to operations team, it will go to the team lead, and then manager will talk to the manager, and there is a separate segregation between the two teams, and which actually delayed a lot of the updates that the new modern team is creating. And this complaint has resulted in a single team called DevOps team. So instead of having two different teams, these two teams got merged together into one team called DevOps team, where both developers and operations team will report to the same lead and the same management, so that there is no wall in between, there is no segregation in between. So whatever they are developing and deploying, they will do it together. Okay, instead of having a separate procedure for developing it and deploying it, both development and the deployment will be happening together as a team. Okay, so the practice started changing. The way we deploy infra started shifting towards developer mindset, I would say. See, I will explain. So business has a requirement. Okay, so developer understands this, and then they create a application code, and then they will run that application on a VM or a server. Okay, this is what happens on the development side of house. And here, same way, the business here, they have a requirement. The infra team understands the requirement, and then they create infrastructure deployment as a code, and then they deploy the infra using the code. So they want they even the infrastructure team mindset started acting like a developer mindset, where even the deployment of infrastructure that is needed for running your application, if they say I need this much amount of CPU, memory, and operating system and configuration, that will be listed in a code. Instead of having it going and deploying it manually or graphically, we will type all those things in a code, and that's how things have changed. Now any deployment that we do, earlier the application used to be a code, but now even the infrastructure is being created and deployed using a code. It can be either using the AWS native or Azure native ARM templates, or we might use the same bicep tool native from Azure, or we might use tools like Terraform, where it can be used for hybrid cloud environment or multi-cloud environment. We can use common tools which can act as a infrastructure as a code to develop the requirement into an infrastructure as a code and then deploy it. If you are talking about AWS, it also has its own CDK or cloud formation tools, where we go and create the infrastructure with development mindset. See here, if you want to change anything on the application code, you need a proper change request process. You need to go through the proper change approval. They will ask what is the failback plan, what is the rollback plan, whether we have tested it in a development environment. So all such questions will also be asked in the infrastructure as a code change. If in case you want to change the infrastructure, so the same set of change management procedure, the Scrum call. So we don't have to wait for 1 month or 2 weeks to make the changes. Instead, all these things will be discussed on a daily basis. If they feel that this can be done on the development environment, they will go and do it in the non-production environment. Once after the changes and testing is done, then very next day you can go and make the changes on the production environment. So things have become very agile. The discussions or approval procedures have been very shortened. The timelines that is needed to bring the changes to attract the market, it has got significantly changed with the agile way of working culture. So the development and the operation team started working in the same mindset. So with the developer mindset, we have started creating and deploying the infrastructure as well as the application. And if to be more precise, see, when the application code is created, what they generally do is, so they create the code, and then the code will be sent to maybe I would say that it will be stored in a source control tool or version control tool, where they have a Git or Bitbucket or whatever repository that the organization is using, and that will be sent to a CI/CD pipeline, continuous integration or continuous deployment pipeline. So your organization might be using tools like GitLab or GitHub or Jenkins will be used, and we might also have a continuous scanning for your security tools like SonarQube or your CFN Lint. A lot of tools are there that will continuously do a security scanning, and we'll also have a continuous validation before we go and deploy the code as a container or as a container or a VM or whatever. So we have a complete DevOps procedure that is being followed on your application code. The same procedure can be used for deploying your infrastructure also these days. So that's where there are a lot of popular tools like Git, GitHub, Bitbucket. I'm just listing only few tools. There are hundreds of tools available. Okay, Jenkins, your Bamboo, or I would say even your cloud native tools like Code Pipeline or Azure Pipeline. We have continuous scanning. We have SonarQube, and a lot of vulnerability testing tools are there like Tenable Nexus or Qualys, and all those things are there. And we also have tools to do continuous validation and deploy the code as a container. So in the current DevOps methodology, in the DevOps framework, we have the agile process gel together with the DevOps mindset, and we are deploying the infrastructure as well as the application as a code into your environment. So with containers, the entire application becomes a loosely isolated environment. Each and every process gets into a small unique service or a package, where if you want to make changes in any of the small module, only that module will be down. The entire application will never go down in this containerized way of deploying things. So the idea of using software containerization technology is mainly for time saving, for any changes you're making, the downtime will be less. When the downtime will be less, the business will get more profit and the business can operate in a much better way. So you get better performance, very less cost reduction is there. So a lot of advantages are there compared to virtualization. Containerization has significantly brought the application changes in a very quick agile way, and also the time that you spend on making modifications will be very less, because you have a lot of developers, lot of DevOps engineers are there who can go and make the changes. And the containerized way of working has significantly saved cost. It has brought a lot of monetary benefits to the business. The biggest challenge is the investment. Okay, so with containerization you need a lot of development activities to do, because you need to do a containerization or modernization of your existing application. We need budget. Okay, so in order to containerize or modernize your application, business needs budget for development to invest on. See here, we have just migrated from physical infrastructure to virtual infrastructure. We had tools like VMware Converter or Microsoft Converter that easily converted the physical operating system, I mean the operating system running on a physical server, to a virtual machine. It was a very straightforward. Only system administrator is needed, and 99% it was a success here in this concept. But with containerization, we need to spend a lot of time and money is needed, investment is needed to containerize or to modernize your application. So software developers has to create the application from the scratch. If it doesn't have easier option to containerize, they have to spend a lot of money to create those software packages, and the containers has to be created, and that containers has to be stored as an image. So here in virtual machine, we used to have a image created and stored. Similarly here also we can have a image created, and it can be stored in a centralized repo. So there are cloud native repositories, and also repositories like GitHub and stuff where you can go and store them. So as I told you, so development team, operations team, and the containers, as I told you earlier, it's a kind of loosely isolated environment, or I would say software package. Allows to run microservices. Okay, so containers has significantly reduced the physical footprint, the underlying OS that is needed, and there is a lot of time saving. Changes we make can be applied immediately. There is no waiting time. So if you have created the container, you have created a new module, it can be run on the same day. So containers are isolated from each other at the application level. There is no segregation at the physical hardware level or OS level, but you can have separate physical server for your PCI compliant applications, and non-PCI compliant applications can be run on a separate hardware, so that you can manage. So in order to run the container, we need to create a container image. So container image is nothing but the software package which contains all the code and dependencies. I've already mentioned it here, so you can just copy paste it if in case you want to have the complete stuff. Yeah, the runtime, the dependencies, scripts, everything will be contained into this, and we will be storing it in a centralized location. We have Azure Container Registry, where you will store all the container images similar to your Docker Hub. Okay, so equal to Docker Hub. So Docker Hub is a centralized repo where we store the images, and using that images we can recreate all the stuffs very easily. So in order to run the containers, you need a base operating system and a platform to run that. So that is what we call it as software containerization instead of hardware virtualization. So here we have a software containerization. This is a OS virtualization method that allows you to deploy and maybe deploy, run, and manage your containers. So the tool that we have, similar to your hardware hypervisor like VMware vSphere, you have Docker. Docker is the tool or the technology. So Docker is a company, it's a tool, it's a technology. Okay, so with the same name, you have the company itself, and the tool name is also Docker, and the technology is also with the same name. So that allows you to run the containers on the operating system level. So containers can be this Docker can be installed on any operating system, either on your physical server. So Docker can be installed on physical server. If you want to have containerized workload on your own data center, you can do it. And if you want to run it on a virtual machine, you can do it. Even if you want to run it on cloud virtual machines or cloud VMs, you can also run the Docker anywhere you want. So it supports multiple flavors of operating system. It also comes with multiple 64-bit and 32-bit as well. So you can run it anywhere. Okay, so there is no limitation. So Docker is a tool which allows you to deploy, create, run the packages, the software packages as a container in your system. So we are at around 7 o'clock. So far, I mean, we have just started with that. So once we get into Azure Container instance, you will understand little more further. So your management of the hosting infrastructure has significantly reduced with this Dockerized concept, and the containers can be created and it can be stored as an image. So that helps you to easily reproduce or recreate when there is a failure. It is very portable. It's very agile. You can recreate systems in very few minutes. So each container is an independent deployment package. It will have its own isolated binary files, libraries, dependencies, configuration items. So if in case something goes wrong with your container, within few seconds you can recreate it. So we are also efficiently using the hardware. With virtualization, we were wasting almost 40% of your CPU, memory, storage for your underlying each of your virtual machine operating system. So here we are efficiently using the hardware. So we just efficient usage of the physical hardware resources. So we are not running 100 operating system. So if you're running 100 operating system, you need 2 terabytes of capacity in terms of your storage. You need at least let's say 2 CPU for your operating system. We are wasting that CPU. And the same like memory, if you need 4 GB of memory for each of your operating system, we are wasting that much number of that much number of memory is being wasted. So we are efficiently using the hardware in containerized area, and the application is very portable, and you have very easy way of recreating your systems. We will see that practically. So Docker is a company. Docker is a tool where through which you are developing, managing, deploying, and maintaining your containers. So Docker is a containerized platform. I would say Docker is a containerized platform, or it's a software hypervisor through which you can develop, deploy, manage. When I say manage, you can migrate, you can ship the container from one system to another system. You can run the container on this particular platform. So Docker doesn't use the VMware hypervisor, or even if you want to run it on a on a virtualized environment, you can still run this. Even you can run your Docker on client OS or server operating system. So you can install locally on your desktop operating system as well as on server operating system. Client or desktop operating system, and it is also supported on server operating system. So the desktop flavor is available on Mac, Linux, and Windows, and server operating system platform is also available. So wherever we are installing this particular Docker, so we call it as Docker engine, or this is the service or the process that runs on the particular server where we are going to run the containerized environment or the containers. When you want to run the containers, you need this Docker engine to be available on that particular system. So this Docker engine, it allows the connection from your remote systems or from your end user if you want to connect. It also provides you the API that is needed, or I would say REST API that is needed for either integration to another application or for connecting from your local machine. You can also use Docker client from where you can also connect to the Docker server. So wherever the Docker engine is running, so that you can consider that as a kind of server. Okay, I would say, so wherever the Docker daemon. So in Linux, we call it as daemon. In Windows, we call it as service. So wherever the Docker service or Docker daemon is running, that is what we call it as Docker server. So Docker server is what is responsible for managing and maintaining the containers. So all the lifecycle management is taken care here. Okay, so in simple words, I would say lifecycle management of your containers. So wherever the Docker engine, Docker daemon is running, so that's the server is called, that is called Docker server. Wherever you are installing the client, Docker client, so it's the command line application or CLI app that connects to the Docker daemon. So you can install the Docker client on any of your machine, and through which you can connect remotely and manage them. So the Docker server daemon is Docker D, and we have this Docker hub where you go and store the images, stores the container images or software packages will be stored in the Docker hub. So we call it as repositories or registries also. Sometimes some people call it as Docker registry, Docker hub, Docker repository. It is a centralized folder, or it is a centralized location where we go and store it, and if in case you need to clone it or distribute it, or if you want to share it, it makes sharing or distribution easier. See, if you log into Docker Hub, you will see hundreds of images available, and any images that you want for running a web application or database application, everything will be available in your Docker Hub. So similarly, you can create your own internal hub. So let me show you how it looks like. So if you go to Docker Hub, you will see hundreds of thousands of images available. Let me continue with Google. So let it log in. See, after you log in, you have this Docker Hub. This is the centralized repository where you can go and find out a lot of different images available. See, if you want to run Nginx web application, see, Alpine is the smallest Linux operating system that is available in your internet. So you can see up to 10,000 images are available. Similarly, you can have your own in-house repository where you can store the images that you are creating. So if you go and look at this Alpine image, so this is a complete Linux operating system. Okay, this is the smallest operating system that you can find in the see, the entire operating system size is 5 MB. See, if you are talking about Windows, it at least needs 20 or 30 GB of space for running the entire operating system. See, for Alpine Linux, it is the smallest Linux operating system that you have. So you can use this Linux image to run an independent container or run an independent operating system also. The entire operating system size is 5 MB. Similarly, there are many different operating system flavor that is available in the market. So this is a complete operating system. Okay, it is the smallest one that is available in the in the Docker Hub. You can use this package. You can use this operating system to develop your application and run it as a container. So you just need only 5 MB space of for your operating system content. And similarly, you can pick and choose any flavor, like instead of using IAS or any other web application, you can also go for Nginx, and you can use different utilities here. So there are a lot of, even you have Ubuntu. See, Ubuntu operating system might be little higher in size compared to your Alpine Linux, I think it might be around 30 to 40 MB, I would think, but not as big as your Windows operating systems. So it needs some amount of space. I will show you after installing it. So, but then Alpine Linux is the smallest one. You can go and pick and choose whatever Linux operating systems you want. For example, if you want Ubuntu or Red Hat, you have a lot of flavors of operating systems available. You can go and you have CentOS also still available as a container. So you can go and download the containers based on your platform of hardware that you are using. Even you have containers for your IBM ARM processors. x86 is very common. So you can go and download the images that the developers have already created, and you can just customize it based on your requirement. So these are all the three important element that form your Docker. Docker has got Docker server, Docker client, and Docker hub, where you have the all the software packages that you store. And you also have a lot of monitoring tool like Docker stats, which can give you information about your usage on in terms of CPU, memory usage, the disk read and write. All these things is available. So these three things forms your Docker. So Docker is a company name, and it has got a product with three different sub products: Docker server, Docker client, and Docker hub. So this came in maybe 10 years back, around 2013. Docker I mean, formed as a company where a lot of people were discussing around the challenge that we were talking about, right? We still have hundreds of operating system to manage. The business is looking for more downtime if in case we need to make changes to your application. So all these things has uh, changed when we got into this Dockerized way of running your application. So we'll take a small break. Okay, so there are competitors for Docker, as I mentioned earlier. We have Vagrant, we have OpenShift, we have VirtualBox, we have Containerd, we have LXC. So there are many competitors for Docker, but Docker was very successful because we had a lot of support. We had a very big, large community available, and lot of different things were getting created on Docker Hub and getting stored there. So it become very popular in a matter of few years, and last 6 7 years Docker has been adopted by big companies like Microsoft, Amazon. They are running their own flavor of Docker application on Azure platform. So Azure Container Instance is a platform. It's a containerized platform that has been developed using Docker technology. So we will take a small break, and when we come back we will start discussing around Azure Container Instance, and we will also try and discuss a little more stuff. Okay, for now, don't worry too much if you are not able to pick up what we discussed. So just go through the sessions that we have in our YouTube playlist. So it has been you have it available in both Tamil and English. You can go through it whenever you get some time. So you will get to understand it in very details. So you know how to install Docker on a server, how to create a package, how to get it deployed. So all those things are available in a very practical approach. You can learn it. So we'll take a small break, and when we come back, we will get to discuss more about Azure Container Instance. And let's see, let me stop the recording. Any questions before I stop the recording? The recording. Okay, so we will get to understand the Azure Container Instance, which is developed based on the Docker platform. So Docker is one of the very popular platform which is used for containerization of your application. It is the most famous containerized platform. So as I told you, there are very good products that you can use, like the Linux kernel containerization platform called LXC, or you can also use tools like Rocket or Cloud Foundry, Vagrant. So these are also being used in some of the organization, and even OpenShift is being used in some of the organization where they are using commercial version of Red Hat also. And even Google process containers are also very popular for running your application process as a separate container. Even VMware has got VMware Tanzo, which is also a product developed based on the Docker engine. So there are many different products that has emerged as part of your containerization success. So the Docker